positive axial location for the turbine rotors relative to the cylinders. To achieve this, it must be able to withstand the unbalanced thrusts due to blade reaction and steam pressure acting on unbalanced areas. It must be free from maintenance except at major outages. Since it is universal practice to use solid couplings between rotors, only one thrust bearing is required in each complete shaft line. It is normally located close to the areas where blade cylinder clearances are minimum and operating temperatures are highest, and is split on the horizontal centerline for ease of assembly and maintenance. All large UK steam turbines use the Michell tilting pad thrust bearing, PIC 1.123. Tilting pad thrust bearing, although the net thrust on the white metal pads in the on-load condition is always in one direction, i.e., typically towards the generator. A second set of pads, termed surge pads, are incorporated on the opposite side of the integral shaft collar to take account of transient reversals of thrust which occur during load reduction and following a turbine trip. In operation, the pad faces are slightly inclined to the face of the thrust collar in the wedge-shaped cavity, thus formed fills with oil. As thrust pressure is applied, the wedge narrows and oil is forced to the restricted end. This ensures that metal-to-metal contact between the pads and the thrust collar is prevented. The pads are shaped and mounted so that each is able to pivot independently. Since the function of the thrust bearing is critical in controlling axial clearances between stationary and rotating turbine components, particular precautions are taken to protect its integrity. Because of the close tolerances between the pads and the shaft collar, the oil supply to the thrust bearing is individually filtered. A portion of the oil is fed straight to the thrust pad shaft collar interface to maintain the load bearing oil film. The balance of the oil supply is diverted around and behind the thrust pads to provide cooling. Since as a result the thrust bearing runs flooded, the consequent churning loss has also to be removed, and therefore this portion of the oil supply is a significant proportion of the whole thrust pad, where measurement is facilitated by the provision of oil pressure nozzles between thick white metal pads and mounted on the thrust and surge sides of the shaft collar. PIC 1.124. Thrust pad measuring system, relying upon decreasing gap at the nozzle head causing a rise in indicated discharge of oil pressure. These nozzles are set at a distance slightly greater from the shaft collar than the normal pad running clearance. A separately filtered constant pressure oil supply is delivered to these nozzles in the discharge. Pressure is continuously monitored as pad wear takes place. The nozzle to collar gap is reduced and the increasing nozzle discharge pressure is locally indicated and alarmed in the control room to give indication of worn white metal thrust pads. Thrust pad temperatures are monitored by embedded thermocouples with local and remote indication and alarm facilities. Less than previous entry.